Bernoulli's principle, the backstory is there is not much backstory. Okay, it only apply a very simple rule where there are only two things here, and this is a very simple subtopic to understand. Okay, because it's a very highly theoretical topic. No calculation at all. No calculation at your level. No calculation at all. It is just theory only. It's like inertia. Remember when we learned inertia, there was no calculation at all. It was only purely theory. So it's a very simple topic to score. Now, Bernoulli's principle only function on two components. Number one, it functions on the velocity of the air. And number two, it functions on the pressure of the air. Okay, so when I say air, okay, I would rather change it lah. We use the word fluid because it can actually happen to water as well. Okay, remember the word fluid. Fluid means what? Liquid plus gas. Okay, so it could be either one. Yeah, it could be either one. Now, how does these two things interact? Okay, simple. Simple rule. Velocity of the fluid and pressure of the fluid. So velocity refers to what? Refers to how fast or how slow the wind blows. Correct or not? Yeah, the speed of the wind. And the pressure of the fluid refers to what? The pressure that is created by the fluid. You know, high pressure, push. High pressure, push. High pressure will push to low pressure. That is a story that you all must know. Since just now when I explained about our monsoon air. High pressure, push to low pressure. So, based on that, you come up with the concept. Velocity is inversely proportional to the pressure of the fluid. When the velocity of an air increases, okay, or the fluid increases, the pressure of the fluid will decrease. When the velocity of the fluid decreases, the pressure of the fluid will increase. Okay, so I can say velocity shares an inversely proportional relationship with the pressure of the fluid. Okay, so basically, whenever it comes to Bernoulli situation, there is always going to be two sides of the story. Okay, this one you got to be very careful. Bernoulli is a comparison. There is always going to be two sides of the story. Okay, kita takkan bincang, okay, only on one side of the diagram. We are definitely going to touch on both sides. Okay, must touch on both sides. Must touch on both sides. Okay, boleh okay, we must always talk about two sides of the diagram. So, velocity low, there is going to be one side velocity low. Velocity high, there is always going to be one side velocity high. Pressure low, there is going to be one side is pressure low. Pressure high, there is going to be one side is pressure high. For example, we talk about the ball just now. Correct or not? We talk about the football. Football, so I thought don't talk about football now. We talk about easier one Okay, the wing. The wing of the aeroplane. Alright, the wing of the aeroplane. The wing of the aeroplane, okay, there is going to be what? There is going to be top and bottom. Top and bottom. So that is what I mean by two sides of the diagram. Okay, kita ada dua belah. Top and bottom. Top and bottom. So there is going to be a velocity of the top here. There's going to be a velocity of the bottom here. There's going to be a pressure on the top here. There's going to be a pressure at the bottom here. So your job is to explain how does these two they interact with each other. What caused velocity at the top to be high or low? What caused velocity at the bottom to be high or low? This is your responsibility. And then talking about pressure. One must be high, one must be low. Your job. Explain what is the interaction between the high and the low pressure. Is it push down? Is it push up? That is your job. So always your discussion must discuss about these two scenarios. Okay, so I'm sure in school if you have covered this thing, your teacher must have shown you a very simple, what do we call, experiment, okay, on how to prove that Bernoulli exists. There are too many things, okay, that can prove Bernoulli. Okay, I will share them with you one by one. Simple one will do. Now, of course, you can try it out yourself. Okay? There's nothing better than try it out yourself. If you have a piece of paper or a tissue paper or whatever, it will make sense that to allow a tissue paper to float to the top, you will try and blow it from the bottom. That is, of course, the wind directly blowing it upwards. But there is another way of getting the tissue paper to lift upwards, not blowing the bottom, but it is blowing the top. So I'm going to turn on my fan here, and then I'm going to show you. Okay? On the side here. I hope you can see. Or on the front here, I think you can see. So blowing from the bottom, of course, allow it to float upwards. But in fact, it doesn't do it as well as if you blow it on the top. Do you see that? You gotta make sure there is no leakage. Right? If it's leakage, it will fail. You gotta put it very close, okay, and you're gonna make sure that you are blowing it quick. Velocity must be high. You are trying to get a high velocity here on the top there. The aircon is fighting me. Aircon is fighting me. You can see here. You can try on your side, yeah. If you don't be near aircon or whatever, you will see that the tissue or the paper, all right, it will be able to float, all right, a little bit to the top. So, of course, normally it doesn't make sense. How can you blow the top but then the bottom push it up? It doesn't make sense, correct or not? Yeah, but using the application of Bernoulli, it does. Let me explain to you how Bernoulli explains it. So this is you, ini kamu lah. This is you, okay, with your nose and your mouth, okay. You ugly, oh. I should take some art lesson, when you are how to draw your face. Okay lah, I give up. I just draw the tissue paper will do lah. Tissue paper. Tissue paper. I know how to do. Like this. Okay. So you see, when you blow this tissue paper, normally when you blow it from the bottom, of course, there is nothing to argue lah. The wind directly comes from the bottom, you get pushed up. But you see, when you blow from the top, how is it able to lift this tissue paper up? Is because when you blow from the top there, you are actually increasing the velocity of the air on the top area of the tissue paper. When the velocity of the air on the top of the tissue paper increase, it will always be higher than the velocity of the air at the bottom. So we can say the velocity of the air on the bottom is lower. Definitely, because when you blow on the top is high, the bottom will be low automatically. Now what happened is based on, the Bernoulli's principle. It says here, velocity high, pressure will be low. Over here, velocity low, pressure will be high. And if you listen to me clearly, I have explained to you just now, pressure high always will push. It will always generate a lift, or it will always generate a force from a high pressure area to a low pressure area. Just now remember I say, the cold air blow to the hot air, from Asia blow to Australia. High pressure always, it will push to the low pressure there. So this is what pushes the tissue paper upwards. Okay, clear. So yes, it is able to do it. Another example. This example you are unable to show you now. Okay, you can try and do it by yourself. What you do is, you can either use ping pong ball or you can use balloon. Okay, if you have a stick here, you hang 2 balloon. Can be anything lah, but make sure that it's light lah. Heavy cannot. Make sure it's a light balloon Okay, so like this Now what happened is, you try and blow between. Okay, when you try and blow between, kita tube di sini lah you blow here. What happened is, again, you can now compare the velocity of the air. So hal laju untuk udara di tengah-tengah ini, dia akan meningkat sebab kamu meniup, dari tengah-tengah sini. Maksudnya dalam kawasan ini, this area here, udara dia akan akan meniup dengan laju. And then of course you compare that to either side the balloon. Over here where there is no wind, velocity is low. Over here there is no wind, velocity is low. So from here you feel it what Bernoulli'S say. Bernoulli'S says that this one will create a low pressure. Bernoulli'S say this one will create a high pressure. This one will create a high pressure. Now based on Bernoulli'S principle, the high pressure area, they will push the low pressure area. So in the end of the day, you should be able to observe the two balloons, they stick together. Okay? Boleh? There are still a lot more. Okay? Slowly. Let me see some questions first. Why in chapter 2.1 in the application of pressure, the position of the tank in the house part, why do they say the tap produces high pressure when the speed of water is high? They speed of water there actually got nothing to do with the pressure of the water, you see. Got nothing to do with the pressure. It is the pressure of the atmosphere, it is a difference in the pressure, all right, which will push it downwards, because when you are at the top, at the bottom there, you are going to have a higher depth of the water. That was using the theory of H rho G to prove. At the top, the tank there, your height, the depth of the water is less. At the bottom there, it is more. So what happened is, it is going to push the water downwards. As you increase the height of the tank and the ground, you are going to create even more difference in pressure. That's the story, which pushes the water down. That got nothing to do with the Bernoulli, because you do not have two sides of the diagram to compare. You see that? There are no two sides of the diagram to compare. If you want to talk about the speed of the water inside, there is no other place you can compare the speed to, because the speed flows in just one pipe. You get what I mean? And the pressure also just flows in one pipe, which is your water pipe from the tanki there. So there is no two diagram. So you see, when I told you just now, right, to describe a situation with Bernoulli, you must establish that there are two areas, because it is the difference which cause them to move. It is a difference between this area and this area which cause it to move. It is a difference between this area and this area which causes it to move. Do you see that? Okay. Another one. Does the Bernoulli apply on a supercar diffuser at the bottom back? At the bottom back. The question is about whether keeps the car planted on the ground. Okay, so I think you were talking about this situation, the spoiler. Is it true? Are you talking about this thing?
Not the spoiler, teacher, but it's the down part of the car, literally under, but right at the back.
So how does it look like? What is it? Is it called bottom back? What is it called?
It's called a diffuser, teacher. You can search it on Google.
It's called a diffuser. It's called a diffuser. I will try to look into it, because I'm not, like I said, I only know a few names. I don't really watch F1. The most significant I know is the spoiler. But I do believe there are other parts of the car which help to create even more of this pressure. But so far I know is this thing. Diffuser. I will look at it. Yeah, it is at the bottom. On the bottom of the car. At the back.
Yes, at the back, teacher.
At the back, at the bottom of the car. Interesting. Okay, I will take a look at it. I'll take a look. Maybe it's to control even more, because the air does flow at the bottom there. So maybe they go to control something there. Of course, we can look into it, that one later lah. You want to really study F1, then you will know. Okay, another one. We can talk about, we have, what else? Okay, we have one more. We can talk about another scenario. We talk about this car. I believe you will have seen this, you have felt this before. I don't know about you, but uh, there was a road leading to my house last time where it looked like this, this is like the barricade of the road, okay, and then this is another barricade of the road. What happened is, um, what happened is this is the lorong which leads to my house, okay, and in order to go inside there, of course, you need to belok kanan lah, you need to turn right. So we will need to stop our car over here, okay. Kita tunggulah, so that it is time for us to belok kanan, because there will be cars coming here, there will be cars flowing on the other side of the road. Okay, so what happened is, while I was waiting here, okay, it could be anywhere really. When I was waiting here, I noticed that the car by itself will rock, left, right, So I was thinking, like, how can the car not move, but then the car will start to rock, left, right, swinging left, right by itself. And then it was after I realized, oh, this is Bernoulli's principle. Why? Because you see, when the car on the opposite side of the road is flying down the road, it will create a high velocity of the air here. When the car is coming down quickly, it brings all the air together with it. So it creates a high velocity of the air here. All right. So the pressure here, they will drop. On this side of the road, because there is no car, so it's gonna have a lower velocity of the air over here. Okay, creating a higher pressure here. So what happened is, this car doing this managed to create a difference in pressure, which pulls the air towards this side, So what happened? The car swing to the right side, Oh yes, that's strong. Okay, yes. And then opposite is true, Yeah, when there is no car over here, yeah, you are gonna have the other side of the story. This one velocity will be high. Boom. This one pressure will be low. This one velocity is low. This one pressure is high. What happened? Now the wind blow the other side, This side, and then the car, it swings to the left. So that's why if you are waiting here, because it takes about a minute for the traffic to calm down, inside there you just exaggerating, but that's what you are feeling inside, rocking like a rocking chair. So this one maybe the next time, okay, you are waiting for the car, you can experience this. There are many opportunity to experience this. The next time you try and notice it. Okay, boleh. Now another one more. Before we talk about the serious application, because these are not in your syllabus. This one you don't really need to know. What you really need to know is the aeroplane, the F1 car. This is just extra one for you. Another one is what we call it as air spray. We call it as air spray paint. Spray paint. We call it spray paint. Okay. So how the spray paint they do is, why not? Let me just pick up a proper picture of a spray paint. 1 second. Okay. 1 second. Spray paint. Because I know my drawing cannot show you accurately. Show you with a proper picture. Spray paint picture. A spray gun. Spray paint gun. Spray paint gun. Okay. Spray paint gun. Something like this lah. You know what this is for, everyone? This one is to there are a few things that can be done. One of the things that can be done is for painting lah. Painting, okay. Some painting they will use it to do painting. Painting, or they could be using it to spray paint the big like wall, kalau kita nak cat dinding, there are some people they don't use the brush, they use the spray. It depends lah. Some of them to make the we call it the gravel wall, feature wall, you know, the wall with a lot of batu one. They use this to spray on the batu. And you can also see this, okay, is for washing the car one. Okay, the one where they make the foam for the car wash. So they're gonna use this. So this thing, they will be connected to a pump, air pump, not water pump, air pump. And then what happened is, in the container on the bottom there, they will fill this up with some kind of liquid lah, depending on what you want to do with it lah. If you want to spray paint, you just put paint there. If you want to do shampoo, you put shampoo liquid lah, in here. So what happened is when you turn on this thing and you press on the trigger, what happened is the engine inside, okay, or the motor inside is going to shoot out a lot of air quickly. So the angin is going to flow inside here. Okay. And the air is going to flow inside here. Let me just, what color can show you? The air is going to flow inside here very quickly, the air. So what happened is, when they are doing this, okay, they are going to create a high velocity in this chamber. Sebab dalam sini ada satu laluan di sini. We call it a chamber. Okay, a chamber, a tunnel, something like that. Then you have leading towards the bottom here. Okay, so what happened is the velocity on the top of the chamber here is high, causing it to have a low pressure. Okay, and what happened is on the bottom of the chamber, this side, you have what? Low velocity, and the pressure here will be high. So what happened is it will push the liquid up the chamber, and then when it mixes with the air, it is going to get sprayed outwards. What do you say? So you can actually use this simple method to create your own air spray. Tonight, later, if you have a straw, okay, if you have a straw, you can do it. Just take the straw, you cut it in half. Okay, the straw you cut it in half. One straw you celup into air. Another straw you put it at the top here. Okay, you try and blow very quickly. The water will get pulled upwards. Seriously, no joke. You try later. Seriously. Okay. Then this is how some of the artists use DIY. They use this to make their spray paint. Don't need to buy this gun thing. This one surely confirm can work because I demonstrate this. This was the one of the things I demonstrate in my science class last time when I was a student in my own physics class last time. So can work, man. Okay, the video is probably on YouTube somewhere. I probably can find it and show you. My teacher last time filmed me and showed to the classroom. It can work, man. This thing. No joke. Explain the straw. A straw, right? You take a straw, you cut it. Don't use what do we call? Don't use too long straw lah. Too long straw, maybe you will lose a lot of air. You use a shorter straw, and then you take one normal straw, you cut it in half, okay, and then one half you celup into air. This is water lah. This is water. You celup into air, okay, and then another one you put it on the top here, okay, you put it on the top here, and then you blow through here. So the story is the same here lah. When you blow through here, the wind here is fast, velocity is high, pressure is low, yeah, and then at the bottom here, velocity is low, pressure is high, so it's going to push the water up. When the water is pushed up, it's going to flow together with your air, then it's going to come out. You try yourself. You try yourself. Okay, one more. I tell you one more example, then I go to the serious one. Okay, one more example is okay, you will see this also happen a lot. Okay, is when you are driving down the highway. Okay, we all know that when you are driving down the highway, you will see a lot of lorry. Lorry as in a truck. Lorry yang tak ada bumbung tu. Lorry yang tak ada bumbung tu. Kat belakang tu. Okay, they have a open. There's an open roof one. So that they can put their things there. After they load on their things there, they will usually cover it with a piece of tarp, we call it. Huh? I don't know if you understand me or not. We call this as a tarp. We call this as a tarp. Okay? So what happened is when you are driving down a highway, of course, at a very high speed, and the wind is blowing. Okay, you all know the wind is blowing very quickly, on the body of the car. Okay, the wind is gushing by. You will think that it should be pushing the tarp towards the body of the lorry, causing it to be very compact. But actually, the opposite is true. Yeah. What happened is when the wind blows quickly, yeah, at 100 kilometers per hour, velocity here will be high, pressure here will be low. Now, inside the lorry, underneath the tarp, di bawah kain ini, velocity is low, pressure is high. So what actually happened is the air on the inside, they will push towards the outside. So that's why you akan nampak this thing. The whole thing is what? Is what we call it as inflated. You will see that it's macam inflated. Because the air inside is pushing outwards. You will see. Then obvious one, you'll be able to see lah. Okay, the lorry. Okay, you'll be able to see lah. If obvious one, you'll be able to see the lorry. Obvious one. Okay, you can see that. Wow, the top will be bulging on the top there. You will see. Okay, because of this story. Okay, so you see so many examples. Still can continue, if you want. Still got a lot. Okay, but of course, I think better not. Yeah, better we talk about serious application. So, one of the things that you'll be asked, of course, is lift. Okay, talking about the story of the aeroplane. So let me show you. Okay, the aeroplane wings. We call it as an aerofoil shape. Okay, aeroplane wing. Cannot simply make on. Aeroplane wing, you will see that most of them, they will have this design. Okay, from the side of the wing, you will be able to see that generally most of the wing, they have this shape. Fat in the front, thin at the back. This shape is called aerofoil shape. Yeah. What actually happened here is, you can see, this shape will cause, okay, dia akan menyebabkan the speed of the air at the top part. Let me just put in my symbols, easy to see. The speed here at the top part, the air will flow at a high speed. Okay, the air will flow at a high speed, while the air at the bottom here, they will be flowing at a low speed. Based on Bernoulli says that the pressure here will be high and the pressure here will be low. So what happened is, you will generate what we call as a lift, okay, which pushes the wings upwards. And of course, the wings are attached to the body of the plane. When the wings get pushed, the body of the aeroplane gets pushed upwards also. This is how the aeroplane flies in the sky. Of course, what is the role of the engine? Why is it that bigger planes need bigger engine? Is it useless? Can we turn off the engine mid-air? No, it is useful. What is the job of the engine? The engine actually helps to create the difference in the speed. Okay, just now we discussed, okay, the speed of the air here is high, the speed of the air here is low. So there is a difference in the speed. Ada perbezaan dari segi hal laju udara. What creates the difference in the speed is the engine. The engine allows the aeroplane to move quickly first. All right, generating this difference in the speed. That's why when it's take off, the aeroplane need time to take off, because the aeroplane is gaining the speed. When the aeroplane is gaining the speed, this thing is happening. Yeah, when the aeroplane is gaining the speed, this thing is happening. When the velocity, the difference in the velocity gets bigger and bigger gap, the difference in the pressure, they will also get a bigger and a bigger gap. The wider the gap is, the bigger the difference between the two pressure, the stronger the lift is generated. So, in another words, we can say the faster the aeroplane goes, the higher the aeroplane can fly. Okay, so most of you previously might think that it is the engine, the air from the engine that is pushing it up. No, you see here, there is no discussion of the air going through the engine. The air going through the engine only one reason, to create speed only. Okay, it is the wing that create the lift going up. That means today, if you have a car which is able to move as fast as an aeroplane, okay, because your concept might be, kalau kita ada satu kenderaan yang boleh bergerak sama laju ataupun lebih laju berbanding dengan satu kapal terbang, then that kenderaan can fly. But no, yeah, even today, if you have something which can be faster than an aeroplane, if you do not have aerofoil design, it still cannot go up, man. Okay, that means today, if you have a car, no matter how fast you go, it will never fly like this. Okay, but then an aeroplane, okay, as long as there is a sufficient speed, as long as there is a proper design, okay, design of the wing important lah. Then you talk about the size of the wing, the length of the wing, the position of the wing. You see? Yes. Whose job is that? That's not my job. That's the job of people at Airbus and Boeing. That's their job to design an aeroplane. Why some aeroplane in the past fail? Sometimes the wing don't design properly. Sometimes the wing don't design properly. You all heard before or not? There is this Boeing 737 MAX. Killed so many people in the last few years of aviation. Have you all heard of the news? It is this model, the Boeing 737 MAX. What is the problem? The design. It is a design of the wing and the engine. Yeah, they did something to it. They moved the design of the engine and the wing on the plane, which causes it to not generate the correct flow of air. This is what people, the engineers at Airbus and Boeing are paid to do, is to study. Because you see, they are going to change the design of the aeroplane. Every time they release a new model, they want it to travel further. They want it to have bigger space inside. They want it to have bigger compartment. They want it to have more toilets inside, whatever lah. So that will also change what? The weight of the plane, all right? The diameter of the plane. So they will need to adjust the wing as they go. So their job is just running simulation every day. Try and calculate what is the correct size of the wing, the angle of the wing, the position of the wing. And only after they go through the successful test, they can come up with this aeroplane. Okay. Clear. All right. So if an aeroplane, what happens if the engine turn off or die mid-air? Will the aeroplane just crash? No, it won't crash. Yeah. Kalau tiba-tiba engine mati, okay, for whatever reason, it won't just crash, It will glide slowly. Why does it glide? Because there is still a difference in speed. Please notice the keywords I'm using. There is still a difference in the speed. There is still a difference in the pressure. The plane will continue gliding until it loses this difference. Because once it loses the difference, nothing is lifting the plane anymore. Clear? Okay, so we call it as an aerofoil. So talking about design, You see? Different aerofoil design. They are all aerofoil, but different purpose. Different purpose. Theory the same. Pressure at the bottom pushes it up. Okay. Now, once you understand the aerofoil shape, you will also understand the aerofoil shape for F1 car. F1 car do what, you know? Anybody can guess what F1 car they do?
It moves around a corner with maximum downforce.
F1 car do this. Terbalik. Flip it the other way around. Because remember, F1 car want to ground the car. F1 want to ground the car. Don't want the car to fly and lose traction. So they want it to push down. They create a downward force. So they turn the air, still aerofoil, but they turn the aerofoil shape upside down. Because now, velocity here is low, pressure here is high, velocity here is high, pressure here is low, creating a difference in the pressure, which is higher at the bottom, lower at higher at the top, lower at the bottom. This create a downward force pushing the car down.